channel, Code with Fernando. In this chapter, we are going to see methods and encapsulation. We will find all these topics. We're going to start with scope of variables. The scope of a variable determines where it can be accessed and how long it exists in memory. There are four main types of variable scopes. We have local variable, method parameter, instance variable, class variables, also called static variables. Okay, let's continue with local variables. Local variables are temporary storage used within methods. Local variables are temporary storage used within methods. They exist only while the method runs and are essential for storing intermediate calculations and temporary data. Characteristics of local variables. They're declared inside a method, constructor or block of code. They're declared inside a method, a constructor of a block of code. They exist only within the method or block where they are declared. Must be initialized explicitly before use, unlike instances of static variables which get default values. They don't get a default value. They cannot have access modifiers like private, protected, or public, since they are not part of an object. Where local variables can be used, we can use them inside methods to store temporary values, inside loops to track iterations, inside if-else statements to control logic flow, inside switch statements to store case-specific data. The scope of a local variable refers to where it can be accessed, while its lifetime determines how long it exists in memory. So, what is the scope of a local variable? It begins at the point of declaration. It ends when the method of block completes execution. That cannot be accessed outside the method or block where they are declared. What is the lifetime of a local variable? They are created when the method is called. As soon as we call the method they have created, they are destroyed as soon as the method finishes execution. Memory allocated for local variables is automatically reclaimed after execution. This is really important. Memory allocated for local variable is automatically reclaimed after execution. Variables must be declared before their use. Attempting to use a variable before declaring it results in a compilation error, also known as a reference error. Why forward references are not allowed? Java processes the variables in order, meaning it doesn't recognize a variable before it is declared. This rule prevents accessing and initializes on non-existing values. The compiler enforces a strict ordering to ensure code correctness. Some common pitfalls related to forward reference. Declaring a variable after trying to use it. Assuming Java automatically recognizes variables before declaration. Local variables are often used in tricky exam questions. Many questions appear to be about inheritance, loops, or exception handling, but they actually test local variable scope and visibility. Some common mistakes or misconceptions. Shadowing instance variables. A local variable can have the same name as an instance variable, but it hides the instance variable within the method. We will see an example later. Assuming local variable persists, once a method finishes execution, local variables are removed from memory. Not initializing local variables. Java doesn't provide default values for local variables, unlike instance variables. Trying to use local variables outside the scope, since they belong to a method, they cannot be accessed in another method. Okay, let's continue with our code demonstration. Let's create a method of type void called calculateSum. Okay, inside that method we are going to create three local variables. The other one will be called b20 and the other one will be called sum. Okay, this will be a plus b. Okay, we are just going to print this. Okay, then we create our main method. Inside that we are going to create our object of type local variable. So we can call this method calculate sum. Okay, let's print this. Okay, we know it's 30. Okay, what if I want to make use of some variable, for example? Let's say 100. I cannot do that You see, I cannot do that because they're local variables. They belong to this method only. So A, B, and sum, they're local variables. They belong to calculate sum method. Only that. So we can use inside this method only. Okay, let's continue with our second example. We are going to create a method of type void. We are going to call this method check number. Inside that, we will create an if statement. So this method will have a parameter of type in. We are calling num. So if num is greater than 0, we will create a local variable, instant message with type string. We'll set positive number. Okay, and then we are going to print this message. Just going to print this message. Else, which means if number is less than 0, I'm going to create another variable called the same message. And I'm going to create this, we are going to name this non-negative. Negative number, negative. Okay, and we are going to print this. So you might be asking, can we have two local variables with the same name? Yes, because this variable belongs only to this scope. Only to this scope. That's why we can create two variables with the same name. Also, this variable belongs only to this scope. Okay, after that, we are going to create our main method. Okay, our main method, and we will create an object of this class. Condition scope, and we are going to call the method check number. And first of all, we are going to try with number 5. Okay, let's see what happened. Yes, positive number. Okay. Okay, then we're going to try the other one, -5. Okay, so we know what's going to print, right? Non-negative number. Okay, okay. What I want to show you here is the, for example, what if I want to print message outside here? Message. Why? Because they are local variables. They belong only to this scope. This message belongs only to this scope. And the other one is the same. They belong only to that scope. That's why I cannot use message in here, because it's outside the scope. Let's continue with method parameters. They're variables declaring the method signature, allowing data to be passed into the method when it's called. These parameters enable dynamic and reusable methods, making them then adaptable to different inputs. Method parameters do not exist before the method is invoked and are destroyed when the method execution completes. They're separate from local variables but share a common trait. They can only be accessed within the method where they are defined. Naming convention must follow Java interface rules. Cannot start with a number, no spaces, must be unique in scope. Typically use camel case, first name, max value, stuff like that. The scope of a method parameter begins when the method starts execution and ends when the method returns a result of exist. Method parameters are not storing object memory, unlike instant variables. Instead, they exist only while the method is running. They can be used inside conditional blocks, for example, if-else loops, for while loops, and other call structures within the same method that cannot be accessed outside the defining method. They cannot be accessed in another method within the same class, in a static method if the parameter belongs to an instance method. Method parameters are essential for passing data into methods and making them more flexible and reusable. Parameters cannot be accessed outside the method they belong to. Local variables are more temporary than method parameters. Loop variables have the shortest lifespan and exist only within the loop. Some best practices always initialize method parameters properly when calling a method. Use meaningful parameter names to improve code readability. Okay, let's continue with our code demonstration. Create a class called font. Inside our font class, I'm going to create an instance variable of type boolean. I'm going to call this tested. Then I'm going to create a method, a public method of type void. It will not return anything. Set tested. I'm creating the setter method, right? Boolean. I'm going to call this val. and I'm gonna assign tested will be equal to val. Okay, that's it. I'm gonna print this. I'm gonna inside set tested method. Tested method. Okay, tested. Okay, now I'm gonna create another method of type boolean. This method will be called is tested. Okay, is tested. It doesn't have any method parameter, and this method. Okay, I want to show you something. What if I want to make use of val? Val here. This val is a method parameter. It's only accessible within this method. Okay, within this method only. That's why I cannot make use of val outside that method. If I want to, for example, do something like that, this is a mistake. Okay, so I'm gonna comment this. So here I'm gonna return a boolean. I'm gonna return test. That's it. I created another class called metaparameter demo. So we are going to try this inside our main method. I'm gonna create an object of type fun. Now I'm gonna make use of this method set tested first. I'm gonna assign true to this. True. Okay. After that, I'm gonna print is tested. Tested. Okay. And fun is tested. Okay. Let's see this in action. It's true. Okay. We know that.